orbitals and quantum numbers. Next class, orbitals and quantum numbers. What it means? In a particular atom, there are a number of orbitals are present. In a particular atom, there is a large number of atomic orbitals are present. Okay, these are distinguished by one orbital to another orbital on the basis of these orbitals are distinguished on the basis of size, shape, okay, and orientation. Size, shape, and orientation. Based on these factors, orbitals are distinguished are known as quantum numbers. Okay, atomic orbitals are precisely distinguished by what are known as quantum numbers. Okay, atomic orbitals are distinguished with the help of quantum numbers. Okay, based on the size, shape, and orientation of orbitals. Okay, each orbital is designated by 3 quantum numbers. Okay, each orbital has specific quantum numbers, that is known as small l, small n, comma l and ml. These 3 quantum numbers are specific for each orbital. Okay, let us consider s orbital. S orbital has fixed these n comma l comma ml values, like that p orbital and d orbitals. So like that each orbital has specific n, l and ml values. Okay, each orbital is designated by 3 quantum numbers labeled n comma l and ml values. Let us look into the first one, principal quantum number n. How it is, what is the importance of principal quantum number? What is the importance of principal quantum number? Let us know. Let us start the point. The principal quantum number n. Principal quantum number n. Okay, it determines what is the significance of principal quantum number n. It determines the size and to large extent the energy of the orbital. It determines size and energy of the orbital. Okay, it only responsible for size and to the large extent energy of the orbital. Okay, size and energy, it indicates the size and energy of the orbital. This value, first point, the value of n is 1, 2, 3, 4 like that, OR, K, L, M, N respectively. Okay, next the value of n increases, the size and energy of the orbital is also increases. Okay, let us look into it one by one with an example. Okay, it is nucleus. We know there are circular orbits. Okay, circular orbit. Okay, these are known as n is equal to 1, n is equal to 2, n is equal to 3. 1, 2, 3. N is equal to 1, n is equal to 2, n is equal to 3, and so on like that. These are also known as K, L, M, and N. Subsequently, n will also come. Okay, you may note it as n is equal to 1, 2, 3, or K, L, M, and shells. Okay. As n value increases, the size and energy of the orbital is also increases. Okay, n value increases, size and energy of the orbital is also increases. What it means? Let us take an example, 2s orbital and 3s orbital. n value increases, size and energy of the orbital also increases. n value 2s orbital, 3s orbital, n value increases, then size s orbital of 3s orbital size is bigger and energy of 3s orbital is also greater than 2s. Like that, n value increases, size and energy of the orbital is also increases. This one has greater size and greater energy. Okay. Next point, the maximum number of electrons possible in an orbit is 2n square. Let us calculate the maximum number of possible electrons in an orbit, 2n square. How do we calculate? N is equal to 1. Let us calculate, put this one into 2n square. 2 into 1 square means 2 electrons. Means in first orbit there are 2 electrons are possible. 2 electrons are possible. If n is equal to 2, principal quantum number is equal to 2, what happens? 2 into 2 square is equal to 2 into 4 is equal to 8 electrons are possible. Okay, 8 electrons are possible. Okay, here 8 electrons are possible in second shell. Second shell, there are 8 electrons are possible based on that formula. Like that, you can calculate next one and the next one. Subsequently, n value increases, n is equal to 3, then you calculate substitute into n square, 2 into 3 square into 2 into 9, okay, 2 into 9, 18. So here 18 electrons are allowed, 18 electrons allowed for this third shell. Okay. Next, the maximum number of sublevels possible in an orbit. Okay, maximum number of sublevels are possible in an orbit is sublevels possible in an orbit n. Okay, what it means? For n is equal to 1, only one sublevel is possible, that is s sublevel. Okay, s sublevel is possible. Whereas in second shell there are 2 sublevels, n is equal to 2. So 2 sublevels are possible, that is s comma p. Whereas n is equal to 3, the number of possible sublevels are s comma p comma d. There are 3 sublevels are possible. Okay, there is a reason why you can understand like that. Okay, next, number of orbitals are n square. Number of orbitals possible in a shell. Number of maximum number, that is maximum number of orbitals. Maximum number of, next point, maximum number of orbitals possible are n square. N square, maximum number of orbitals. Maximum number of orbitals, n square. Let us think about how do we know n square is possible. Okay, here let us put n is equal to 1 there. It means n square is 1, means number of orbital in first shell is equal to 1. Here only one orbital is possible. Whereas n is equal to 2, then the number of possible orbitals are n square, means for n is equal to 2, the number of orbitals are 2 square 4. Okay, 4. Here the number of orbitals, s orbital, p orbitals are px, py, pz. The total 4 number of orbitals are possible. Okay, whereas here the number of orbitals possible, n is equal to 3. Put n is equal to 3 on that formula, then you can get 9 orbitals. 3 square 9, n is equal to 3, n is equal to 3. you can get 9 orbitals. Okay, 9 orbitals. Okay, 9 orbitals. How we can get 9 orbitals? D sublevel contains 5 orbitals. P contains 3 orbitals. S contains only 1 orbital. So finally, 5 plus 3 plus 1, you can get 9 orbitals. Okay, total number of orbitals are 9. The formula is valid. Maximum number of orbitals possible in a orbit. Maximum number of orbitals are possible in a particular orbit is equal to n square. Means for n is equal to 1, the number of orbitals are possible 1. Okay, for n is equal to 2, number of possible orbitals are 4. For n is equal to 3, number of orbitals possible are 9. So in this way, you can understand principal quantum number n. N gives this much of information. N value increases. Size and energy of the orbital also increases. Okay, size and energy of the orbital is also increases. Okay, you can understand the concept in this way. Okay. Next one, azimuthal quantum number. Let us look. Okay, let us understand the concept. Second point, azimuthal quantum number L. It defines three-dimensional shape of the orbital. The three-dimensional shape of the orbital. Shape of the orbital is the main motto from the azimuthal quantum number L. Okay, for a given value of n, the possible values of L are 0 to 1, 2 to n minus 1. How do you understand this one? Easy. Let us take for n is equal to 1, L values are 0. N is equal to 1, that is 1 value. This is 0. N is equal to 2, there are L values are 2 values, 0, 1. For n is equal to 3, there are 3 values, 0, 1, 2. If n is equal to 4, what you get is 0, 1, 2, 3 like that. Okay. If n is equal to 5, you can get L value 0, 1, 2, 3, 4. The number n is equal to 4, there are 4 values, 1, 2, 3, 4 values, 3 values, 2 values. These values indicates subshells. L value indicates subshells. Okay, L is equal to 0. Okay, let us write down. L is equal to 0. It is S subshell. Okay, it is known as S subshell. Okay, it is S subshell. Okay, L is equal to 0 means it is belongs to S subshell. Okay, for L is equal to 1, it is belongs to electron present at P subshell. If electron present in L is equal to 2 means electron present in D subshell. Okay, next L is equal to 3, electron present in F subshell. Okay, L is equal to 4, electron present in G subshell. So like this you can understand subshells. Okay, it represents the subshell to which electron belongs. Okay, if electron present L is equal to 0 means electron present at S subshell. Okay, if electron present in L is equal to 1, then electron present at P subshell. In P subshell there are 3 orbitals. We know in P subshell there are 3 orbitals, Px, Py, Pz. Okay, like that. Orbitals are present in subshell. These are the subshells. In subshell there are different orbitals are also present. Okay. In this concept, you only know it represents the subshell to which electron belongs to. Okay, it cannot talk about it cannot deals with the orbitals, it only deals with the subshell in which electron are present. Okay, in which electron are belongs to. So this one and this one is the enough for the understanding the azimuthal quantum number L. Azimuthal quantum number L. Okay, you know this is the basic idea from the 10th class. Okay, next quantum number, magnetic quantum number. Magnetic quantum number. What is? Let us see. Let us see the concept. Magnetic orbital quantum number. This is third one. Magnetic orbital quantum number ML. What it indicates? It says the spatial orientation of the orbital with respect to the standard set of coordinated axes. We know the orbital's orientation with respect to x-axis, with respect to z-axis, with respect to y-axis. So, the orbital in which direction it is oriented, in which direction it has. Okay, with p orbital, px orbital has its orientation x direction. Py orbital, the lobes are directed towards the y axis. Like that z orbital, pz orbital, like that are those orbitals, those lobes are directed towards the z axis. That is the reason, that is the way you can understand it. The orientation of the orbital, in which direction they are. Okay, it is indicated by spatial orientation of the orbitals, certain coordination axis. For any subshell, for given value of L, 2L plus 1 values of ML are possible. 2L plus 1 values of ML are possible. The ML values are given here, minus L, L minus L minus 1, comma, L minus 2, 0 to 1, so on, L minus 2, comma, L minus 1, L. So, how to understand this one? Let us take another example. For given value of L, let us suppose L is equal to 0. L is equal to 0. What is the value of ML? Okay, ML. Okay, ML has 0. ML value is 0. Okay, only it has only 0 value. Okay. There is some formula to L plus 1, put this one L is equal to 0, L is equal to 0, 2 into 0 plus 1, you can get 1. For S orbital, L is equal to 0, there straight away gives us the 1 value. So, ML value is 1, the ML value is 0, here it is the 1. Okay. Like that you can understand L is equal to 1, then what happens? ML values relationship. If L is equal to 1, then we understand that ML values is equal to, put here minus, okay, minus 1, then 0, then you can observe 1. So 1, 1, that repeat. Okay. 1. From this you can understand that minus 1, 0, 1. So L is equal to 1, the values are minus 1, 0, 1. Okay. Then put this one into here, 2 into 1 plus 1. The total number of values are 2 plus 1, 3. So 3 values are possible. Like that, L is equal to 2, then ML values are minus 2, minus 1, 0, plus 1, plus 2. Okay, you may say it is plus 1. Okay. Then total values are 5. Okay, put here 2 plus 2 plus 1, 4, 5. So, that is the reason why 5 values. Here there is values are 3, here the values are 1. So, this value is 1, this value is 3 values, this value is 5 values. So in this way you can understand magnetic orbital quantum number ml. Okay, ml indicates number of orbitals, orientation of the spatial orientation of the orbitals. Okay, there are 3 types of orbitals are possible here. 3 types of orientation is also possible. Okay, here for L is equal to 2 subshell, L is equal to 0, 1 subshell, there is only 1 orbital are possible. For L is equal to 1 subshell, there are 3 types of orbitals are possible. These orbitals are in different directions. L is equal to 2, L is subshell, L is equal to 2, there are 5 types of orientations, or 5, first of all 5 different orbitals are present. They are in different orientation, different axis, they are present in oriented in different axis. Okay, like that you can understand magnetic orbital quantum number ml. Okay, next one. Okay, next one is spin quantum number. Spin quantum number is represented by S. What it indicates? It indicates the direction of the spin of the electron. Okay, direction of the spin of the electron. So let us take an example and you can understand better way. Next one, the values of S in clockwise direction is represented by plus of, and anti-clockwise direction is represented by minus of. Okay, how to understand this one? Let us take an example. Helium is electron configuration is 1s2. These electrons take an orbital. The representation of electrons are like that. This one is clockwise. The upper side is clockwise direction. Okay, clockwise. It is represented by plus of. And this one is this is opposite spin. This is clockwise, this is anti-clockwise. Anti-clockwise direction of spin. Okay, it is treated as minus of. Okay, clockwise represented as plus of, anti-clockwise represented by minus of. Okay, it is one is plus 1, another one simultaneously it is goes to minus of. Okay, in this way you can understand this one. Okay, one electron is in clockwise, another electron is in opposite direction. Okay, it is like that. Okay.